All right, so we'll balance an equation, and then we will. Well, actually, let's do this all together. We'll balance the equation, and we'll do the mole things all at once, and we'll see if we can put it all together in one big problem here. I'm going to type this so it's not too messy, but. All right, so here's this type of question. I'm going to make this bigger. All right, so here's your question, and I want you to work on it for a little bit, and then we'll look at it together. Calcium oxide reacts with water to form calcium hydroxide. How many moles of calcium hydroxide can be formed from 5 moles of calcium oxide? So there's a lot of stuff going on here. Let's take it apart a little bit first, and then you can give it a try. So first, the ultimate thing we want to answer is this moles thing. So what do we need first before we can ever answer that type of a question? We need a balanced equation. If we're talking about the moles of one versus the moles of the other, we need the balanced equation together. So the first step is to put together a balanced equation. So give this a try. Don't worry about the mole part for now if you don't want to, but see if you can write a balanced equation for that process that's described there. I should also note, for those of you, if you have computers or other devices, these notes on Blackboard, they update as we do them. So if you want it right in front of you, it's right there. What? Yep. Magic of technology.
Thanks.
If you're totally stuck or you're stuck on a part, ask the people around you or just put it down. Calcium oxide reaction. All right, I see some good equations. So I'm going to go through the equation now. If you want to listen, that's fine. If you want to go on and work on the mole thing, do that. And then we'll do the mole thing later. All right, the most errors I saw looking around, which mostly looked fixed. I don't know if that was an issue from talking to people or what. But at first, most of the errors I found were from not putting the compounds together properly, not looking at the charges of the ions and building the compounds. So let's make sure we can do that. Calcium oxide, we'll look at that one first. So calcium is a +2 ion. Oxide is a -2 ion. So when you put that compound together, that means that you only need one of each, 2 + 2 -. So the calcium oxide is just CaO. reacts with water. And then to form calcium hydroxide. So again, with calcium hydroxide, we have the +2 calcium. And we have hydroxide, which is one of the polyatomic ions on the list, which has a charge of -1. So to make a compound from those two, we need 2 of this one so that there can be overall neutral charge, 2 plus, 2 minus. So that formula is going to look like this, CaOH2. And now we can start balancing. For this one, I think it just is balanced, right? Okay, great. Yeah. Unless there's only one of them. But if you put any subscript number, you should put the parentheses. Okay. So this is balanced as is, so that was easy. Let's answer the rest of the question then. How many moles of calcium hydroxide can be formed from 5 moles of calcium oxide? So this one might be easy to see just because the numbers are really simple in this particular one. But let's go through and do it the right way, just so we can practice it for when it's a little more complicated. So we're told that we have 5 moles of calcium oxide. Okay. And we want instead to know how many moles of calcium hydroxide can be formed. We get the ratios or the numbers from the equation. In this case, everything's just 1. So that makes it pretty simple. We form 5 moles of calcium hydroxide, since there is a 1-to-1 ratio between those in the formula, or in the equation. Make sense? Can I try another one? All right. All right, I'll make this bigger so you can see it. Gold 3 sulfide reacts with hydrogen gas to form metallic gold and hydrogen sulfide. How many moles of hydrogen gas are needed to react with 3.2 moles of gold sulfide? And I'm going to change this a little bit. This one is one that breaks the rules a little bit. Hydrogen sulfide, if we followed our rules that we've been talking about, should really be called dihydrogen sulfide. So even though that's not really the official name of it, it's because it's a weird exception, not something I'd expect you to know. You can think of it as dihydrogen sulfide or dihydrogen monosulfide, because it is a covalent compound. Yeah. What does it represent? Check. So one other thing that I'm noticing a lot, hydrogen gas. Remember we talked about the bonding, the covalent bonding with hydrogen? Hydrogen gas does not just exist as individual hydrogen atoms. How does it exist? H2, yeah, two hydrogens bind together. So make sure that when you're writing hydrogen gas, you're writing H2, and that's going to affect your balances. Yes. Yeah. Good. No, we're not going to do an official break tonight, so just head it out. Yes, I think the quiz may be working. But I will. It's true that you're being following the rules exactly. You have the lowest possible numbers. But you're right. The point of the balanced equation is so you can calculate most of it. In that case, it doesn't matter if it's double digit this or anything. So I would consider that correct. Yeah, but we got rid of that. No, I would tell you. Yeah.
No, I'm referring to how like some things have like an S and some don't, and some like just part of what it's just they know what they are and they talk about it. No, that wasn't. That was just like.
No.
Yeah.
I was just wondering what she was
Referring to.
So that one.
So did you have
Yeah, my first lab practical
Tomorrow you're doing it? Oh, yeah, it is.
Like, okay.
I've done this thing.
Except for
Oh, yeah. Right.
What do you think? Yeah. The compounds are all correct.
Oh, yeah.
But it's not that.
I was wondering.
All right, it looks like most people have the compounds, or at least have some good tries at the compounds. So I'm going to write them down too. Yep. So there are the compounds. This is not balanced. Some people asked for a little more time for balancing, so I'll give you a little more time. If you've already gone through and balanced it, try to do the mole part. If you got different compounds from these, check, see if you can figure out where you went wrong and why you went wrong, and learn from that. Let me know if you don't know where you went wrong or what happened. Yes. Most of the single atom or single element gases are something like H2O2 and 2 F2Cl2. There's also bromine and iodine. Those aren't gases. But I don't think it's that. So like, they won't all be like this. There are other ways of formulas. Or you're given the whole balance equation. Yes. Yeah, the idea is by that second. The third is study it. Yeah. Okay. Okay, so that's, so we got this part, we got this plus 3, this minus 2. But if you take one of these or one of these, you've got minus 6 total for these. And plus 3. You see what you need to write 2 in there also. Think about the total charge of the compound. If you take your compound plus 2 and minus 6. So if you have to do plus 3, you need minus 2. That's not 0, that's. If you add some more minus, but yeah. So the way you put it here, you got 3 of the minus 2, so that's minus 6. And then you got 1 of the plus 3s, which doesn't quite take any plus 6.
Oh.
Yeah.
Like, oh, I'm using. And I was completely like they were off when I went in.
All right, should we continue? Okay, so we've got our compounds here. Balance them now. We can start wherever we want. I'll start with the gold, I guess. So 2 on the left, 1 on the right. So we can put a 2 here to match those up, right? Then we can look at the sulfide or the sulfur. 3 on the left, 1 on the right. So we got to put a 3 here so that we can have 3 on each side. And then finally the hydrogen. We need to put a 3 here so that that balances as well. Does that work? Got that? Okay. So let's do the moles. Again, same calculation that we've been doing. We start with that amount that we're given, 3.2 moles of gold sulfide. And we want hydrogen gas. That's what's being asked for. How many moles of hydrogen gas? So there's our H2. And then we need to put our numbers in from the equation. So a 3 and a 1. And that means that our final number is going to be 9.6 moles of hydrogen. Right? So I should say with the exam, you need to be able to do all this stuff, but there won't be a lot of problems that kind of have this whole thing all together, because the way I like, if I asked you a question like this, and let's say you got the equation wrong. If you got the equation wrong, or if you even got one compound in the equation wrong, that means that everything else after that is also going to be wrong. So unless I just want to give you like all or nothing, it makes it really hard to grade for partial credit, because I want to use your numbers that might be wrong, but then maybe you did the calculation right. So it ends up kind of being a nightmare. So there won't be a lot of big questions like this on the exam, but you need to be able to do all these individual skills. So you need to be able to put an equation together from the names, balance the equation, and calculate the amount of moles of one given the other one. And those are mostly separated out in the book if you look at the practice problems in chapter 4. All right, other questions about this stuff? Okay, what else should we go through? Should we take a look at the objectives? Let's see. So remember, that's what we're basing all of this off of. Oops. Through where we went last week. So that means we stop at number 8 here. So we didn't do all these yet, right? We'll do those next week. So everything up to number 8 here through all of this stuff is going to be on the exam. So, question? Angie? The molar mass, sure. Let's try this. Calculate molar mass of ammonium carbonate. Go for it. So try it out, and then we'll go through it together. But yeah, sure, we'll do that next. So that's right. You just add up all of the atoms. So that compound is all right, let's take a look at this. So I saw a lot of compounds that looked good eventually, some not so good at first. Remember that anytime you're writing down a formula for an inorganic compound, for an ionic compound, you need to make sure that the ionic charge is balanced so that you have an overall neutral compound. In this case, that means ammonium, NH4, which is +1, and carbonate, CO3, 2-. If you still don't know the names, formulas, and charges of those 7 polyatomic ions, get on that because that will definitely be on the exam. We look at these 2 ions and see that one is +1 and one is -2. So we need 2 of the +1s to balance that out. So that looks like this. And the way that we draw that in a formula is we put parentheses around the NH4 and say there's 2 of them. and then the carbonate. So that's the formula. And you need the formula first to be able to calculate the molar mass. So now that we've got the formula, we can calculate the molar mass looking at the mass numbers. I'm just going to round to the whole number because it's not specified. So in that case, there would be 2 nitrogen. Those are 14 each. Then 8 hydrogen, because we've got 2 of the NH4s, so 8 total hydrogen. And those are 1 each. Then we've got carbon, which is 12, and 3 oxygens, which are 16 each. Put that all together, and what do you get? Anybody do it? 96? And that's grams per 1 mole, grams per mole. All right, so that's how we calculate a molar mass. Now let's look at some questions that use the molar mass. How do we use the molar mass? So we'll use it in 2 different ways. One is to calculate the number of moles from a given mass, and the other is to calculate a mass from a given number of moles. So first version of that is how many moles of ammonium carbonate? No, you don't have to. However you want to do it. The rule. Remember that we said that there are rules for this, but we didn't do that in this class. So our kind of basic rule is whatever is in the question, whatever it's asking, use about the same number of decimal places. But for all of them, I won't take off points for rounding unless you like do some crazy rounding or something where everything's just 1. But yeah, I won't take off points for rounding wrong. So how many moles of ammonium carbonate are in 150 grams? And then the second way to ask that is how many grams or any given number of moles, let's say 0.34 moles. All right, so try those out. Try to set them up like this with conversion problem, like any other conversion problem. In this case, we're not using numbers from a balanced equation, but we're converting from one unit to the other using the molar mass as a conversion factor. So see if you can set that up and solve it, and then we'll go through it together. So you're starting with that 100. Then you're using the molar next. The molar mass at 96. That tells you. What do you have to follow? Given the number of grams, so that means grams and top.
Yeah.
Yes, that's so actually.
Yeah.
I'm just tired of editing.
But you understand. Yeah.
Wait, is from the first one?
Yeah.
Is that what we do? From the equation at the top, it's 2
Yeah. 12.
12 or 1.2?
12.
12?
Yeah.
Oh, okay. Yeah.
So you got a different number?
Oh, because I just wrote exactly.
No, your number is only 2 times 14.
I mean, I think so.
A group exam? And let's do it all for that. Why don't I just give everybody a 100% of the exam and watch the
Yeah. Yeah. 5-star review.
I know, right?
I got it.
Isn't that funny how, like, if I did a bad job, like my job, everybody would be happy?
Yeah.
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 Less work.
Well, think about it. We're not really going to use this stuff.
Sure you will. It's more important than you'll ever learn.
Yeah? For real?
Maybe.
Maybe some things, but not everything.
Someone in your future career can
What happens if that?
report that you did.
I have a different theory. I think schools want to Sorry. No, but like you're right.
My first degree, I was
I mean, it's not, it's just like, you know, it's not your degree. I just don't know.
But that's why maybe that's why you
Right.
should care, right?
You're right, you're right. You know, if you write it, I mean, 25%. It's just not.
All right, let's take a look at these conversions. All right, so we're going to use the same conversion factor, which is this up here, and we just have to make sure we're interpreting it correctly. So when we write a unit like that, grams per mole, or we did the same thing back in chapter 1 with density, that means 96 grams per 1 mole. So that tells us the relationship between grams and moles for this particular compound, right? And the reason I write it that way now is we have to keep those units straight. And with a lot of you, which was great, I saw you use the units with your conversion and get it all totally right, and then just flip those numbers. So it's important to know which number goes with which unit so that that all stays straight. So in this case, we're going to go 150 grams of the compound, and then we'll convert from grams to moles. And so that's 96 grams per mole, which comes out to about 1.5, so 1.56 moles. The second example is a similar conversion, but the opposite. We're now told a number of moles, and we have to calculate a number of grams. So 0.34 moles of the compound. And now we're going from moles to grams. But notice the numbers from the molar mass stay with their units. So the 96 still goes with the grams. The 1 still goes with the mole. Now we got 32.6 grams. Yeah? All right. Okay, so that's molar masses. What else? What else we got?
we just doing the edit? All of it?
Everything up through here. Not these. That's later. So everything up through number 8 in the equations and reactions will be on the exam. So what else do you not feel great about here?
What's the difference between milliliters and cubic meters? Go up. It was like the. Yeah.
Milliliters and cubic centimeters?
Yeah, that one.
Yeah. What's the relationship between milliliters and cubic centimeters? Do we know? Yeah, they're equal. 1 milliliter is 1 cubic centimeter. That's an important conversion to know for especially medical applications, because a lot of times you'll see things dosed or ordered in one or the other, and it's important that you know that those are actually the same. So if you see like, now we write cubic centimeters 2 different ways. One is the more kind of mathy way, which is centimeters cubed, because it actually is a cubic unit, like there's centimeters times centimeters times centimeters. But you'll also sometimes see it written as CC, which stands for cubic centimeters. That's the same thing. Those are all the same volume as a milliliter.
You're gonna give us the conversion.
I will give you I'll give you the equations for temperature.
We do a something where we have to write like the.
I don't know what that is, but
Like the. Find it.
what is the thing that you want to write?
Like, how do we rate the equation into like full? Like,
The names, the compounds into the names?
with, like,
All right, let's try one of those.
yeah.
So you want not like we were doing where the name is and then you have to write the compound, but when I write the compound, you write the name.
Yeah.
Okay, let's try a couple of those. We got there eventually. I do now, yep. All right, let's pick some good ones. So how about TLS? Try that one. That's an L, yep. Because there is no T element, so it's Ti is titanium, TL is thallium. Let's also do I think we did this one before, but that's okay. P2O5, and then let's do
You also do some like Italian.
yeah. All right, so let's do these three. Write the names.
What's the abbreviation or what is it for 5?
Penta.
Oh, yeah.
All right, should we look at these? You ready? These are tough ones. These are tough ones. So the first one, we find that TL element, which is thallium. You can see it down at number 81. It's not one we hear about a lot. Makes a pretty good poison. People kill each other with it every now and then. Yeah. There was a pretty famous case in Boston of a woman who killed her husband with it. She worked at a chemical company and was just like, and it accumulates in your body, so you can just like give somebody a little bit every day, and then they just die.
You know what I mean?
Well, they still lots of stuff that kill people, but she, in this case, she was a chemist, so she like took it from work. And she probably would have gotten away with it, except that she bragged to all her friends, or she didn't brag, but she would always like talk about how she wanted to kill her husband. So when he died, they were like, maybe she killed him.
Right, so they do like slip it in the drink.
Yeah, I think that was it. Yeah, it's pretty bad. So anyway, all the stuff down in that area of the periodic table is pretty nasty. You got mercury, you got lead, tin, all that stuff. This is not great. Cadmium.
Is it tin and like a lot of stuff? Not like by itself. You know what I mean?
Tin is in some stuff, but you don't want to like, get it in you too much. All right, so anyway, thallium sulfide. So we've got thallium and we've got sulfide, but we also have to ask about whether or not we put the parentheses with the charge. And this one is particularly tricky in that area because this one does have it. But if you look at the periodic table, it's not strictly in the middle. But all those metals underneath that stair-looking thing, except aluminum, we would use the parentheses with because they can take different charges, just like all the ones in the middle. So thallium is in that as well. And we've seen some examples with lead. I think there was some in the homework in the last quiz. So we have to figure out the charge. To figure out the charge, you write down all the parts of the formula with the charges that you do know. So in this case, we have TL, whose charge we don't know. And then we have 1S, whose charge we do know because sulfide is always -2. So we look at that and we say, okay, well, sulfide's -2, so then thallium must be +2 to balance that. So our full name should be thallium 2 sulfide. There's also thallium 1 sulfide that exists. All right, next one. We've got no metals in this next one. So that tells us it's a covalent compound, and we name it a little bit differently by specifying the number of each element. So what did you call this one? Anybody get this one? I saw a lot of good ones. Diphosphorus, pentoxide, yeah. Diphosphorus, pentoxide. If you wrote pentaoxide, like with the A, that's fine. I wouldn't mark that wrong. And then finally, we have another ionic compound between, what are the names of the two ions here? Potassium is one, and sulfate is the other. So not sulfide, but sulfate. Be careful, they're very similar words, but very different ions. Do we use parentheses here? Parentheses? No, why not? Yeah, it's a metal that always has the same charge. Potassium and everything else in its group is always +1, so there's no need to say what the charge is on potassium. All right, so that's how you name stuff. That's one example from each of the 3 categories that we looked at of ways of naming. So again, remember by Wednesday, make sure you know those polyatomic ions. Make sure you have a good sense of that flow chart of how you figure out whether something goes in this type of name or this type of name, this type of name. And then the last skill that's sometimes difficult is figuring out the charge on the metal from the other ions. Yeah.
So aluminum, silver, and zinc are the only 3 that you wouldn't use as parentheses in if they were mixed with.
No, everything in group 1A, everything in group 2A, and aluminum. And you're right, zinc also, but we said we're not gonna go there. Do any different exceptions. So pretty much, if you can't look at the periodic table and the column in the periodic table and figure out what the charge should be, then you can. All right. What else?
Wait, I have a question.
Yeah.
So for covalent compounds, we don't add the
Right.
And
Right.
ionic we do.
Right. The covalent compounds all are like this with the prefixes. So I'm not hearing anything, but let's say this: if you feel good, you're ready. You don't need to stick around, but don't feel pressured to leave just because other people are leaving and you also want to go home. If you have questions, stay and ask your questions. Let's work it out so you can do well on Wednesday. Yes. Atoms and elements number 5, sure. The electron configuration. Yeah. So the way I would ask this is something like this. Electron configuration. Draw the electron configuration for silicon and give the number of valence electrons. So something like this. Draw the electron configuration for silicon and give the number of valence electrons. Now, there's a couple different ways you can draw the electron configuration. That's the thing about the shells. How many electrons are in each shells? So there's the way that's like the book does it with the rings around the center, or there's the way that we did it in class with the buckets. So you have 2, 8, and 8 for your buckets, right? So let's try that. So here's our 2, 8, and 8. And we figure out the total number of electrons we need. So for silicon, that would be 14 electrons in the neutral atom. And then we just fill those electrons in. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So this is an electron configuration. This is all you need to do. If you look up electron configurations in the book, they go into a bit more detail with these S and Ps and things. We're not doing that in this class. We just want to know which level has which electrons. So our first level is full with 2, our second level is full with 8, and our third level is only partially full with 4. So how many valence electrons would that be? Just 4 from that outermost level. Another thing I could ask is which shell or which level contains the valence electrons, and in this case it would be 3, right? What do we call the rest of the electrons? Do you remember the word for those? The core electrons, yeah. So there are 10 core electrons and 4 valence electrons in silicon. So these are all core electrons. Yeah. Yeah. Number 4. So that's the 7 polyatomic ions that you need to know. Yeah. So that's saying we can go back to that chart. I don't remember which batch of notes it was in. I think it was. Not that one. The other batch of notes. There we go. So there's your list of polyatomic ions. So you need to know the name and the formula and the charge for each one, and then how to put them into compounds together properly. Yeah, make sure you have that list. This is all on Blackboard. Yeah.
I was gonna ask on Connect, is there any way you could like push? Because I tried to do it today and it says like I won't get, like I can still do it, but like I won't get credit.
Yeah, so if you do it, and then I can set the date back after when it's done, and you should get credit for it.
Just give me 0 point.
Because it was
I did
late.
it today,
Yeah.
What would the questions be about the electron configuration?
So mostly like looking at bonds and deciding if they're polar or not. That's the important part of that. Right. Or I don't know, just go through some of the questions, but if I don't include the electronegativity in the actual values, then you can figure it out from the ways we talked about in class. Like if it's two atoms that are bound that are kind of far apart on the periodic table, then you can assume those are probably going to be polar. If it's two atoms that are the exact same atom, it's got to be non-polar. That kind of stuff.
I have a question.
Mm-hmm.
I was asking, it's like
Right. Yeah, but covalent bonds don't, or the atoms in covalent compounds are not charged. They don't actually have charges. They're just different. There's just different numbers in them. Right. What's he got?
Wait, so how many quizzes did you say we could drop?
It depends on how many we take.
Okay.
So we will keep the top 5 quizzes for the semester. If we take 8, we'll drop 3. If we take 10, we'll drop 5.
No, I'm think like one more.
Maybe, yeah. Well, let's see. We're not going to do more than 1 a week because probably, right?
Yeah.
So right now it's week 5, which means we've got 10 weeks left, basically, with like Thanksgiving, whatever. And there's 3 exams, and we won't have them during exam week. So yeah, we'll probably have like 7 more.
Okay, so how many quizzes will that drop?
5.
Drop 5. Oh,
If
7
we
more
have
quizzes
10
if we already
quizzes,
had- Oh, okay.
then
okay,
we'll
we
drop
already
5.
had- Okay. So you would only have to do like 5.
Right.
And 3 more, okay. No, wait, yeah.
I'm getting mine, but
Oh, wait, what did you say?
I just said, do we have enough for tonight?
Yeah.
Yeah, that was a good review.